Hey physics people, good afternoon. Welcome to Doc Onco's Physics. My name is Keith Onco, and today what we're going to be doing is looking at how to solve a parallel circuit problem. It's similar to what we did in solving a series circuit problem, but the rules are a little bit different, but the concepts are basically the same. What we're going to do is we're still going to use our graphic organizer, I think that's a different thing, right? Graphic organizer to solve the problems, and we're still going to have a set of rules, but the rules have changed. The rules changed a little bit for a parallel circuit compared to a series circuit. So in a series circuit, what we had was, draw a little series circuit up here. We had a battery and we had a set of resistors, and the defining thing for a series circuit was that the current that left the battery only had one path to go through, right? There were no options for the current. In a parallel circuit, the thing that really defines a parallel circuit is if we look at the circuit below the one I just drew, the current that leaves the battery, this we call I total here, say, when it gets to this point right here, and we call this a junction point, it has an option. Some of the current can go down through this resistor down here, and then some of it can go through this resistor down here. So some can go through R1, and some will go through R2. It has options, okay? And that's the basic difference between a series circuit and a parallel circuit, or how to identify one. Notice, if you will, in our parallel circuit, we have 12 volts across our battery, which means that essentially I've got 12 volts up here and I've got 0 volts down here. So if I do the same thing that I did with the series circuit, I trace a line so it goes up along here and it goes up along here. I'm not going through any components. So when I get to this point here, I could ask, well, if I had 12 volts originally right there, and I've only simply gone through a wire, right, and this 3 amps here, that's just indicating what my total current is, that's not a device there. And I get to this point here, this junction point right here, what's the voltage that I've got right there? Well, it stays at 12 volts, right? So I've still got 12 volts there. Well, and now I can continue along this line here, right? I've still gone through no devices, right? Just along a wire. What have I got right here? Well, I've got 12 volts right there as well. Okay, let's look at the bottom of the battery. Well, I've got 0 volts down here. Well, if I trace a line over here and I get to this point right here, how many volts do I have there? Well, I've got 0 volts. I continue along here, going just through the wire now. All right, no voltage drops or anything. How many volts do I have here? I've got 0 volts there as well. So if I now look at the different resistors in my circuit between the top here and the bottom here, if I look at the top and the bottom of R1, what's the voltage difference or the voltage drop? It's 12 volts. If I look at R2, the resistor over on the right-hand side, this guy right here, what's the voltage difference between the top of the resistor and the bottom of the resistor? It's also 12 volts. So what can we say about the voltage in a parallel circuit? The voltage in a parallel circuit is the same across each and every resistor. It does not change. So where in a series circuit, the voltage split among the resistors. In a parallel circuit, the voltage is the same across each resistor. Okay. Well, we've already seen that the current that leaves the battery, I total, leaves the battery, right, and comes up to this point right here, and it splits. Okay, so that's the next thing we're going to look at here, parallel circuit rule. The current splits up through each path. So the total current splits into the current, say, I1 here, and I2 over here. And so what's the total current going to be? Well, the total current, I total, is going to equal I1 plus I2. And if we had more resistors in parallel, it would be I3 plus however many currents we have for however many paths that we have in the parallel circuit. Okay, so the current just adds up. Well, think back to the series circuit. In the series circuit, it was the voltage that split up and the current was the same. In a parallel circuit, they're flipped, right? The voltage is the same and the current splits up. Okay, now one thing that is truly different in a parallel circuit is how we determine the resistance. Before we do that, let's actually calculate the equivalent resistance for our circuit here, and we're going to use our graphic organizer table that we've got over on the right hand side over here. So we use this for the series circuit. We're going to use the same kind of graphic organizer for the parallel circuit, where the rows across we can solve by using Ohm's law, V equals IR, all right? And the columns we can solve using the rules, right? The parallel circuit rules right here, right? So the columns obey the parallel circuit rules, and the rows obey Ohm's law, V equals IR. Well, let's see what we've got. We've got a total voltage of 12 volts, okay, from our circuit up here. We've got a total current of 3 amps, okay, because this is the current that's leaving the battery, right? I've got 3 amps leaving the battery, and before it splits, well, you know we have 3 amps. What else do we know? We know R1 is 12 ohms, okay, so 12 ohms. So if I put the 12 down here in the wrong place, let me get that out of there. That 12 should have been here for volts, okay. We don't know what R2 is. All right, so all we really know is we know what R1 is, we know what the total voltage is, and we know what the total current is. Well, if we know the total voltage and the total current via Ohm's law, V total equals I total times R total, all right? So we have 12 volts is equal to 3 amps times R total. What is R total then? It's going to be 4 ohms. Okay, so we have that. All right, what else can we do here? Well, we know that we have 12 volts total in our circuit, but if we come up here and we look at the parallel circuit rules, we said the voltage is the same across each resistor. So I can fill a 12 in here, and a 12 in here, and the 12 there. So now, what other information can we build? Well, I have 2 pieces of information in the top row here for R1. I have resistance and I have voltage. So again, using Ohm's law, voltage divided by resistance is current. So 12 divided by 12 is 1 amp. Okay, so I know that. And I now have 2 pieces of information in my column to the right, the current column. And what does it say for total current? Well, I total will equal I1 plus I2. Well, I total is 3 amps. I1 is 1 amp. What does that make I2? It's going to have to be 2 amps because 1 plus 2 equals 3 amps. I now have enough information in the second row for R2 to figure out what R2 is, right? Voltage divided by current, again we're using Ohm's law, 12 divided by 2 is going to give us 6 ohms. I now have my total, all the information that I could possibly get for this parallel circuit. But let's take a look at our total resistance. Our total resistance is 4 ohms, right? Well, my resistance for R1 is 12 ohms. My resistance for R2 is 6 ohms. Well, 4 ohms is less than either one of those. So there must be another way, another method that we have to use to achieve the total resistance in a parallel circuit, and there is. We can either get it using Ohm's law, or we can get it using a law called the reciprocal law. And that law is this. That law says this. The total resistance, all right, RTP, total resistance in a parallel circuit, is equal to the reciprocal of all of the reciprocals of the resistances. So it's going to be 1 over R1 in this case, plus 1 over R2. All right. If we had more resistors, it would be plus 1 over R3, you know, and so on and so forth as to however many resistors we have. So let's work this out. Well, RTP in our case is going to equal 1 over 1 over 12 plus 1 over 6, right? And so when we do this math, what do we get? Well, we get 1 over 0.25, okay? And what's 1 over 0.25? It equals 4, which is the same as what we got down here, okay? Here's a sanity check for you. If you get an answer that's less than 1 for your equivalent resistance or total resistance for a set of parallel resistors, the odds are that you forgot, oh, what happened to my pencil there? You forgot to take the reciprocal of what you got down here, okay? You did all the math down here, you did the hard work, you came up with, say, 0.25, but then you forgot to take 1 over 0.25 to get the final answer, okay? If you get a resistance less than 1, the odds are that's what happened. Because usually in most of the circuits that we deal with, the resistances are much higher than 1. Let's try another problem, another parallel problem. All right, so I've restated the rules over on the left-hand side. And in this case, we've got a slightly different circuit. It still has 2 resistors, but the information given is a little bit different. So let's take our information and fill in the table that we've got. Well, it says the voltage of the battery is 6 volts. So I'm going to come down here and put a 6 there. And it says that the current running through R1 is 2 amps. So this is a 2 here. And the current running through R2 is 1 amp. And that's all the information that we're given. Okay, so what can we do with that? Well, we don't have any 2 pieces of information in any row, but we do have enough information in the current column, right, to come up with a total current, right? And what do we do to get the total current in a parallel circuit? We just add them up, right? Our rule right there. So 2 plus 1 is 3 amps. Okay, so our total current is going to be 3 amps. Well, we also know that the voltage does not change, right, in a parallel circuit. So if I have my total voltage is 6, well, my voltage across each resistor is 6. So it's getting a little bit easier now, right? So I want to know the resistance of R1. Well, it's going to be the voltage divided by the current, Ohm's law again. All right, 6 divided by 2 is going to be 3 ohms there. For R2, it's going to be 6 divided by 1. It's going to be 6 ohms there. Now, we could either find the total resistance using the reciprocal formula, or in this case, it's pretty easy. We could just use Ohm's law. The total voltage, which is 6 volts. The total current is 3 amps. Right? Voltage divided by current would give us resistance. So 6 divided by 3 is 2 ohms. Okay? Let's verify that using the reciprocal formula. So RTP is going to be 1 over 3 plus 1 over 6. Okay? And when we plug that into the calculator, we get 1 over 0.5, which equals 2, which is the same thing that we got there. So this is how we solve a parallel circuit. Okay? The important thing is to make sure we understand the parallel circuit rules and we apply them just in the same way that we applied series circuit rules. Really important to understand series circuit rules and parallel circuit rules, because the next thing that we're going to look at is combining series and parallel circuits. And when we do that, we really have to make sure we apply the right rules to get the right answers. Hope this helps and have a great day.